Good evening, everyone. So we will do the next topic today. This is about capacitors. I'll give you a brief introduction of capacitors, which we learned before exams. There is something called a parallel plate capacitor. Parallel plate capacitor. What is a capacitor in the first place? A capacitor is something that stores energy, right? It is a system used to store energy. A capacitor has two plates which are parallel to each other, right? First plate is full of positive charges. Second plate is full of negative charges, Okay, negative charges. Now, the electric field in between them is sigma over epsilon zero. We learned this, right? Sigma over epsilon zero. I repeat, we have two parallel plates and the plates are kept side by side. Okay. And first plate is positive charges. You know, its surface charge density is plus sigma. What is meant by surface charge density? Surface charge density is total charge divided by total surface area, right? Total charge divided by total area is called surface charge density. All right. And this is minus sigma. Second one is having minus sigma. We even proved that the electric field here is zero. We have done this couple of times. All right. Electric field in between the plates is sigma by epsilon zero, right? And the electric field is always from positive to negative, as you can see, negative. The spacing between the plates is small letter d. So this is the setup of a parallel plate capacitor. I repeat one more time. There is something called capacitance, a capacitor or a condenser. Capacitor is also called condenser. And for a condenser, there will be two parallel plates side by side, the left plate and the right plate. Okay. And then I told you first plate has positive charges all over it. Second plate has negative charges, right? And outside the plates, electric field is zero. Outside the plates, electric field is zero. Inside the plates, electric field is sigma over epsilon zero. Sigma over epsilon zero. This is the electric field inside, where sigma is called surface charge density, and its value is total charge. Its equation is total charge divided by total area. All right. And the distance spacing is small letter d. And for this assembly, capacitance was calculated to be epsilon zero A by d. Epsilon zero is called permittivity of free space. It is a constant. Its value is 8.85 into 10 to the power minus 12. Epsilon zero value is 8.85 into 10 to the power minus 12. Okay. And this is with air inside. If there is air inside the capacitor, this is how it reads, epsilon zero A over D. Now, what about a medium? If you fill it inside, if you fill the inside with a medium like water, paper, wax, etc., all right. If you're filling it with a medium inside, tell me, there will be another equation, epsilon zero, epsilon R A by D, where epsilon R is called relative permittivity or dielectric constant of the medium. Correct. Okay. So we have like two capacitances now. One with air in between the plates. If you take the capacitor and interior is filled with air, it is capacitance with air, which is epsilon zero A over D. What is epsilon zero? Permittivity of free space. What is A? Area of a single plate. What is small letter d? D is the separation between the plates. Okay. And if you fill it with the medium, it is epsilon zero, epsilon R A by D. Epsilon R is relative permittivity of dielectric constant. And right here, we even defined epsilon R. You can divide Cm divided by Ca. You can divide Cm by Ca. What do we get? If you take the ratio, epsilon zero, epsilon R A by D by epsilon zero A by D. What do we get upon cutting? Epsilon zero, area, d cut. Finally, you get Cm over Ca is equal to epsilon R. This is the equation relation. This is the definition of epsilon R. Epsilon R is what? Relative permittivity of a medium is the ratio of capacitance of a capacitor with the medium inside to the capacitance with air inside. Basically, it is a ratio, right? Ratio of what to what? Ratio of capacitance. Okay. Ratio of capacitance with the medium to capacitance with air. This is called epsilon R. Now, this is what we learned so far in the last class. Okay, right. So, I'll have a quick repeat one more time. We have something called parallel plate capacitor. There are two plates side by side, two plates side by side. This is like water stored in a tank. Imagine this to be a water tank and charges to be water. All right, just like you store water in a tank, you are storing charges in a capacitor. All right. Capacitor assembly looks like this. There will be two plates side by side. They are called parallel plates. All right. First plate has positive charges. Second plate has negative charges. And inside there is an electric field sigma by epsilon 0. All right. And the capacitance equation. What is the capacitance equation? Epsilon 0 A divided by D. Capacitance of a parallel plate capacitor is epsilon 0 A by D. Epsilon 0 is called permittivity of free space. Permittivity, it's a constant, 8.85 into 10 to the power minus 12. Okay, A is the plate area and D is the separation between the plates. All right. And then if you fill it with a medium, like I told you, you can fill the interior with water or paper or wax or some dielectric, mica, anything you want. Understood? Capacitance will change. What is the capacitance now? Epsilon 0, epsilon R, A by D. Epsilon R is a characteristic of the medium. That medium has a certain value for epsilon R. Got it? And then what? You take the ratio Cm to Ca. It is epsilon 0, epsilon R, A by D over epsilon 0, A by D. Epsilon 0, A by D gets cut. You are left with epsilon R. So epsilon R definition is what? It is the ratio of capacitance with medium inside to capacitance with air inside. Now, this is the crux of what we learned so far in capacitance. Now, I'm going to tell you something. The derivations I won't be taking today. I'll take it in the next class only. Two more small derivations are there. All right. I have the capacitor like this. This is plate number 1 and this is plate number 2. And right inside, you're going to introduce a slab. Look at this. You are introducing a slab inside like this. This is a slab. All right. I'm introducing a slab inside a capacitor. See this? This is my capacitor plate. This is my capacitor plate. Okay. Right. Plate number 2. Plate number 2 here. Right. And right inside, I'm introducing a slab. I'm introducing a slab. All right. Okay. So the spacing between the plates is small letter d, like I told you before. Look at this. This is plate number 1. This is plate number 2. Okay. Plate number 1 and plate number 2. Got it? So you got the plates like this side by side. And inside, you are introducing a slab. Not completely filled. Partially filled. Got it? You are filling it with a slab. What kind of a slab? It's a conducting slab. Conducting slab. Like I said before, first plate has positive charges all over it. Tell me. Second plate has negative charges all over it. Am I correct? Am I correct? Then what? If you introduce a slab inside, this is a conducting slab. This thickness is called T. This thickness is T. All right. Now, what happens inside a conductor? Last class, I told you, charges never stay inside a conductor. Charges will always stay on the outer surface of a conductor. All right. Charges will always stay on the outer surface of a conductor. I can tell you. Look at this. This is positive, right? This positive will pull all the electrons to the surface. Am I correct? All the electrons to the surface. All the electrons on the slab will come to the surface. Similar way, the other side, which has lost electrons, will be, tell me, the losing electrons will make it what? Positive. Am I correct? So that is how it looks like. What is the electric field now? Inside the slab, electric field is what? It is 0 because no charge inside, right? No charge inside. So electric field now exists only in the shaded region. Only in the shaded region. Look at the shaded region. The slab, interior of slab does not have an electric field. In this scenario, capacitance is given by epsilon 0 A by D minus T. The derivation is not there in syllabus anymore, but I'll do it in class. Okay. Because in your school, they'll teach this. Epsilon 0 A by D minus T. So whenever a slab is introduced, it is epsilon 0 A by D minus T, provided it is a conducting slab. What if it is a dielectric slab? Dielectric slab means like paper or wax, insulating slab, mica, etc., etc. What is the difference? Few charges can go even inside the slab. Few charges. In the case of a dielectric, there will be a different electric field. Different electric field. In this portion, what is the electric field? Do you remember? Sigma by epsilon 0. Even in this portion, what is the electric field? I said beforehand, sigma by epsilon 0. But this is dielectric, right? Which will have sigma by epsilon 0, epsilon r. Because whenever you think of dielectric, you must incorporate epsilon r into the equation. Am I correct? I'll repeat one more time. Look at this. Look at the scenario. We have like two plates side by side. This is called a parallel plate capacitor. And what are you doing now? You can introduce a slab inside. What kind of a slab inside? This is called a conducting slab, like copper slab. You're introducing a copper slab. Tell me what? When you introduce the copper slab, it is metal. Metals have charges resting on the outer surface, right? Correct. No charge would stay inside. I have told you many times it is safer to stay inside your car when lightning strikes. I must have said n times in your class. Tell me, electric field inside is what? Electric field inside will be 0. In this case, electric field inside is 0. Electric field exists where only? Outside the slab. Outside the slab. Look at the shaded region. This region has still sigma by epsilon 0. Even this region has sigma by epsilon 0. And this will result in the capacitor, capacitance being epsilon 0 A by D minus T. We will derive it later. Understood? Now, what is the difference if it is a dielectric? Dielectric. This is a conducting slab, right? What if it is a dielectric? It is not, the electric field is not 0 anymore. It is some other value. How much? Sigma by epsilon 0, epsilon r. It is a different electric field inside. So the equation also will be different in that case. What is the equation? I call them C dash and C double dash. Okay. Or let us call them C conducting and C dielectric. Conducting slab introduced, dielectric slab introduced. The equation is what? Epsilon 0 A by D minus T plus T by epsilon r. This is the equation for dielectric slab introduced. Now these are the topics remaining, the derivations. Chapter is finished. We're going to do questions today. All right. Epsilon 0 A divided by D minus T for conducting slab introduced, dielectric slab introduced, epsilon 0 A by D minus T plus T by epsilon r. Let us check if it is correct or not. Conductor, epsilon r value is infinity. Conductors, epsilon r value is infinity. If you put infinity here, what will you get? Epsilon r value, if you put infinity, any number by infinity is 0, right? So that term will vanish. You will get this equation, right? Correct. So conducting slab equation is epsilon 0 A by D minus T, and dielectric slab equation is epsilon 0 A by D minus, tell me, T plus T by epsilon r. That is our first equation. All right. Second thing is, energy stored in a capacitor. Look at this. If I take a capacitor and give charges to this by connecting a battery, what will happen? Energy will be stored in the capacitor. It is like this. This is your apartment complex. On top of this, there is a water tank. How do you take water up to this? How do you take it? Will water go up on its own? Tell me, water needs energy to go up, right? You need somebody to pump water, right? Pump water up. Am I correct? Who does the job? That is called an irrigation pump, motor, right? So the motor pumps water up. Correct. Work done by motor is converted to its energy. Same way, this is like a motor, which is pumping charges onto the capacitor. How does it happen? I can tell you. This is positive. Positive will pull one electron out of it. Positive has the capacity for attracting negative. One electron is torn out of it. So this will become one positive. At the same time, negative will release one electron to this. Second electron is taken from this, one more positive. Second electron is released to this. Third electron, fourth electron. This is how the capacitor gets charged. Got it? The capacitor is getting charged here. What is the energy stored in the capacitor? The derivation used to be very, very important. Now it is deleted. The derivation, only the equation would be enough. Half CV square, first equation. Second equation is half QV. Third equation is Q square by 2C. Why do we need three equations? From the equations you can understand, because this equation involves what and what? C and V, right? C and V. This equation is in terms of, tell me, Q and V, and this equation is in terms of Q and C. All right. So energy in terms of C and V, energy in terms of Q and V, energy in terms of Q and C. Got it? So let's have a quick summary. We will write then. We'll do the questions. Okay. I repeat. First of all, we have something called parallel plate capacitor, which we learned in the last class. Okay. Parallel plate capacitor has parallel plates side by side, two plates. Okay. Two metallic plates. First plate is having positive charges. Second plate is having negative charges. Here outside the electric field is 0. Even here the electric field is 0. But in between the plates, the electric field is sigma by epsilon 0. We proved it many times already. Okay, electric field inside is sigma by epsilon 0. If you have the plates like this, electric field here is 0, electric field here is 0, electric field here will be sigma by epsilon 0. Correct? Sigma is total charge by total area. The spacing is small letter d, plate area is capital letter A. Okay, then I told you capacitance is given by, with air it is given by epsilon 0 A by D, and with the medium, if you fill it with a medium, completely fill, not partially fill, completely fill with a medium. It is what? Epsilon 0 epsilon R A by D, epsilon 0 epsilon R A by D, and you take the ratio Cm to Ca, it is epsilon 0 epsilon R A by D by epsilon 0 A by D. Epsilon 0 cut, area cut, dd cut, you're getting epsilon R. You have the definition of epsilon R here, right? It is the ratio of capacitance with the medium to capacitance with air. Capacitance with the medium to capacitance with air. Then we come here, we have two cases. Introduction of a conducting slab. Introduction of a conducting slab. You take the plates, you're introducing a slab inside. Okay, capacitance is epsilon 0 A by D minus T for a conducting slab. For a dielectric slab, it is epsilon 0 A by D minus T plus T by epsilon R. Got it? What is conducting slab? What is dielectric slab? Conducting slab means like copper. Okay. Dielectric slab like paper. One is copper, the other is paper. That's it. All right. So when you do that, the capacitance is what, Kripa? CD is what? Epsilon 0 A by D minus T plus T by epsilon R. Got it? Right. Then we have the energy equations. Energy is given by what? Half C V square. Energy of a capacitor is half into C into V square. Right. C is the capacitance, V is the potential difference. Energy is also given by half QV. Energy is also given by Q square over 2C. Q and C. Q is the charge and C is the capacitance. Got it? Got it? And how is charging done? Like I told you, when you connect the capacitor, one by one, electrons are pulled out from the first plate. When one electron is taken, that becomes one positive charge, right? When somebody loses an electron, he becomes positively charged, right? Same way. Now this is positive, the other side is full of negative. That is how charging is done. Okay. Now after some time, it is like, just imagine there is a water tank and a pump is doing work to fill water inside. So water is being stored in it. Same way, charge is being stored in it. Understood? After some time, the capacitor will be saturated. Saturated means full of charges. Got it? Which is called steady state for a capacitor. All right, steady state for a capacitor. Anyway, while charging a capacitor, the energy stored is given by half CV square, Q square by 2C, half QV. Derivations are deleted. Okay, 100% sure it is deleted. We'll have numericals though. All right. One question which this is what I started the chapter with. Q against V graph. I don't know if you remember or not. Q against V graph. Q is directly proportional to V. We drew the graph in class this way. What they are asking to find the area under the graph? Can you tell me? The area looks like is it like a circle or something? Tell me, it's a triangle, right? What is area of a triangle? Half into base is V, right? Into height is Q. Half into V into Q. Okay, look at this and tell me, half into V into Q is what? This energy stored, right? I think it was there in your paper this time. I saw it somewhere. Or I don't remember if it was in DPS or... Anyway, it was there in one paper I saw. Half into V into Q, energy stored. This is energy stored. So, area under the graph is actually what? Area under the graph is Energy stored in the capacitor. Energy stored in the capacitor. Got it? Let us start writing. All of you got it? Right. Let's start with the recap. Okay. First is, we have like two plates side by side. Plate number 1, plate number 2. First plate is having positive charges. Second plate is having negative charges. Okay, the electric field here is 0. We have done this so many times now. Electric field is 0. Electric field inside is sigma by epsilon 0. Electric field inside is sigma by epsilon 0. And the spacing between them is small letter d. Okay, the setup is called a parallel plate capacitor. This arrangement is called a parallel plate capacitor. Okay, this arrangement is called parallel plate capacitor. Okay, now, first of all, you write the capacitance. What is the capacitance with air? Epsilon 0 A by D. Hope you know what epsilon 0 is. Epsilon 0 is permittivity of free space, right? Now, fill it completely with a medium. It is epsilon 0, epsilon r, A by D. Okay. Now, write the third one, epsilon r. You divide them, C medium by C air is equal to epsilon 0, epsilon r, A by D by epsilon 0, A by D. Epsilon 0, epsilon 0, A, D, D cut. Cm divided by Ca is equal to epsilon r. Cm divided by Ca is equal to epsilon r. This is how the definition of epsilon r is done. Epsilon 0, epsilon r, A by D. Okay, epsilon 0, epsilon r, A by D. This is what we learned in the last class. Okay. Now I'll write today's topics. Tell me when it is finished. Now you can write this introduction of a slab. Introduction of slab. You are going to introduce a slab into a capacitor. Draw the capacitor first. We have the capacitor plate this way, like this. We have like two plates side by side. So these are the plates, okay? These are the plates. First plate is having what? Positive charges. Second plate is having negative charges. And they are separated by a distance d. Right inside, you are introducing a slab. This is a slab. Just draw this. Draw the slab inside. The slab has a thickness of, I said already, thickness is T. What's happening now? The conducting slab will have charges coming to the surface, right? Correct. All the charges will appear on the surface, right? All the electrons will be pulled to this side. Just put the minuses on this surface. Third, fourth, fifth, sixth, seventh. So on the outer surface, we have like positive, 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 positive. Okay. So inside the slab, what is electric field? All the charges are outside. So if you draw a Gaussian surface inside, it won't enclose any charge, right? So electric field inside will be what? 0, right. Electric field inside is 0. Write it. Electric field inside is 0. and look at the green shaded area. The green shaded area that is outside the slab. There we have electric field. The electric field is sigma over epsilon 0. Sigma over epsilon 0. Okay. Just write. Once you have written, you can write. You can write. Underneath, you can write. Electric field inside the conducting slab is 0. Oh, number 1, conducting slab. I forgot to put it. It is in fact conducting slab, like copper slab, iron, gold, silver. Okay. It is a conducting slab you have introduced. So what is the capacitance in this case? I call it C conducting. CC. C equal to epsilon 0 A by D minus T. I'll be deriving this later. Okay, epsilon 0 A by D minus T. It is not relevant anymore, but I'll be doing this. Okay, some batches still do this. Epsilon 0 A by D minus T. Capacitance is given by, you remember having seen the derivation? No, not yet. Epsilon 0 A by D minus T. Some teachers don't do it anymore. Epsilon 0 A by D minus T. Okay. Now, this is conducting slab. Now, draw the case of dielectric slab. Number 2, dielectric slab. Dielectric means what? Non-conducting. Dielectric means insulator. Dielectric means insulator. Dielectric slab. Do the same thing one more time. Same capacitor I'm drawing one more time. I have the capacitor a second time. First plate is full of positive. Second plate is full of negative. You are going to introduce a dielectric slab this time. It is a dielectric slab, okay? Tell me. Here, I told you electric field inside won't be 0 anymore. Few charges will go inside. Few charges will stay inside, unlike a conductor. All right. Inside the slab, there will be electrons. There will be charges. Here, charge inside is what? 0. That is why the electric field is 0. But here, electric field is little different. Sigma by epsilon 0, epsilon r. Inside the slab, electric field is sigma by epsilon 0, epsilon r. Because unlike a conducting slab, dielectric slab has free electrons inside, or not free electrons, charges inside. Okay. Then look at the green shaded area. That region has same as old. Right. Same electric field as the old case. What is it? Sigma by epsilon 0, sigma by epsilon 0. So basically there are two electric fields. One inside the slab, the other one outside the slab. Tell me what you're going to write. Electric field inside the dielectric slab is sigma by epsilon 0, epsilon r. C dielectric is equal to CD stands for C dielectric. Okay. Epsilon 0 A divided by D minus T plus T by epsilon r. I'll tell you how this will come in numericals. Tell me when you're done writing. Finished. All of you finished? Everyone online? Could you please tell me, do you need more time? So write this: energy stored in a capacitor. Energy stored in a capacitor. Energy stored in a capacitor. Write this: energy stored in a capacitor. Sure. Previous slide. Right heading: energy stored in a capacitor. Okay, energy stored in a capacitor. Right. When a capacitor is charged by a cell, when a capacitor is charged by a cell, when a capacitor is charged by a cell, energy is stored inside it. When a capacitor is, no problem. When a capacitor is charged by a cell, when a capacitor is charged by a cell, how is it done? Think of water being stored in a water tank. Okay. In order to store water in a tank, you have to pump water up, right? Or in order to take you from here to your house, you know, the engine of the car has to do a work, right? That's it. So you need some sort of a work, right? The work is done by the cell. Understood? The cell is pumping charges onto the capacitor. Got it? Actually, how is it done? Like I told you, one by one, electrons are torn off from the first plate. Am I correct? This positive terminal will take one by one, electrons one by one from the first plate, right? Okay. So you can, what did we write? Why did we write anything? When a capacitor is charged by a cell, when a capacitor is charged by a cell, when a capacitor is charged by a cell, energy is stored on the capacitor. When a capacitor is charged by a cell, when a capacitor is charged by a cell, energy is stored on the capacitor. When a capacitor is charged by a cell, energy is stored on the capacitor. Energy is stored on the capacitor. Okay. It is given by energy is stored on the capacitor. When a capacitor is charged by a cell, it is stored on the capacitor. Okay. It is given by when a capacitor is charged by a cell, energy is stored on the capacitor. It is given by, I've written on the board, half CV square. U is equal to half CV square. U is equal to half CV square. U is equal to half QV. U is equal to half CV square. U is equal to half QV. And U is equal to Q square by 2C. Q square by 2C. Energy stored is given by U is equal to half QV. Energy is equal to half CB square. Energy is equal to Q square over 2C. Okay. Then write the note also. We will do the questions now. So how do we do this? You complete this triangle. You know that the area is triangular in shape. So you can find the area half into base into height. Half into base. Base is B. Into height. Height is Q. Area is half into, tell me, Area is half into Q into V. It is what? It is energy stored. So basically, the area under QV graph is what? It's a previous board question. Area under QV graph. It is the first question on the worksheet. Area under QV graph is energy stored in the capacitor. Slope of the QV graph is capacitance. We did that in class. Slope of this graph, Q by V, no? Capacitance. Area under the QV graph is energy stored. Energy stored. All of you finish this? All right. Now I'm going to tell you, look at this. I'm going to tell you, hey, listen, I'm going to tell you 32 different possibilities which can come as questions. And listen, if you know the technique, it's going to be easy. Otherwise, the questions will be very difficult. Multiple times ask questions. I have seen your school notes on this. It's complicated. Okay. Just see this, whatever I'm telling you. Look at this. First of all, you must know a few things. Number one, if a capacitor is connected to a cell, still connected, imagine it is still connected. Battery connected. They say battery connected. Battery connected means voltage must be constant. There is constant supply of voltage, right? Battery connected. There are two cases. Battery connected case and battery removed case. Battery connected and battery removed. If they say battery connected, that means voltage is constant. What if battery is removed? Look at this. Imagine your dad is funding you every day and one fine day he stops funding you. What will happen? Whatever cash you have in hand will stay constant, right? That means the amount of charge will stay constant. If battery is removed, charge will remain constant. So there are two scenarios. Number one, battery connected. Battery connected means still the funding comes in every day, right? So voltage is constant. The supply is there. Got it. But you know, once the funding is stopped, what happens? Whatever you have will stay constant. Charge is constant. So you just have to know these two things. This is very, very important. You know, I'll put it on the next slide. Battery connected. Just remain, but just understand. Battery connected. Battery connected means who will be constant? Voltage will be constant. Battery disconnected or battery removed, who will be constant? Charge will be constant. Say it again. Battery connected, voltage is constant. Battery removed, charge is constant. See what I'm doing now. Number one, I'll tell you all the cases. Number one, slab introduced, battery connected. Slab introduced, battery connected. Look at this. It is not given in the reader, but you have to learn. Every time they ask this question. Slab introduced, battery connected. Okay, so you have a capacitor. Battery is still connected. You are introducing a slab. What happens when a slab is introduced? Original capacitance was epsilon 0 A by D, right? Correct. That is why I put the recap in the beginning. Epsilon 0 A by D, am I correct? And when you introduce a slab, tell me, conducting slab, epsilon 0 A by D minus T. Am I correct? What happens to denominator? Denominator used to be D. Now it is what? D minus T. Denominator decreases. So capacitance value increases. Same thing will happen for dielectric slab also. Okay, so just know one thing. Upon the introduction of slab, be it conducting or dielectric, capacitance will increase. Capacitance will increase. All right. If you introduce a slab, capacitance will increase. That is purely mathematical. Look at this. Capacitance is epsilon 0 A by D. When you put the slab in, it is epsilon 0 A by D minus T. Denominator decreases. Denominator used to be D. Now it is D minus something. Correct. Minus means less. So denominator is less. This value will be more. Right. Capacitance increases. Number two. Tell me about this battery connected. I told you battery connected. Battery connected, who must be constant? Voltage must be constant. So voltage is constant. Voltage, I'm writing this way, constant. Okay, voltage is constant. People, please write. Third one, V and C are written. Now I can write Q. How about Q? Q is CV. Do you remember that equation? Charge is given by C into V. We learned this many times, right? Now look at this V. V is a constant. What's happening to C? Increases. V is constant, C increases. So automatically charge also increases. Understood? Fourth one, what will happen to energy? Energy, you have three equations, half CV square, half QV, Q square by 2C. Correct. Which equation you will choose? You have to choose the equation with constant quantity in it. Who is constant here? Who is constant here? I have three equations, half QV, half CV square, Q square by 2C. But I can't use this. Why? Because both Q and C are, C is increasing, Q is increasing. There are two variables in an equation, right? Correct. I can't do it. So I must choose which equation? The equation with constant quantity in it. Who is constant? V is constant. So I'm using half QV. Even half CV square is fine. Got it? Now tell me what's happening. Half is a constant. V is a constant. What about Q? Q increases. Correct. Q increases. So energy also increases. Now this is one case with 4 subcases. There are 8 such main cases. 8 into 4, 32. Understood? This is slab introduced, battery connected, right? Now slab introduced, battery removed. Then slab taken out, battery connected. Slab taken out, battery removed. 4 cases. Then plates are moved apart, battery connected. Plates are moved apart, battery disconnected. Plates are moved towards each other, battery connected. Plates are moved towards each other, battery disconnected. 8 into 4, 32 cases altogether, but all can be done if you know these 2 points. Battery connected, voltage is constant. Battery removed, charge is constant. Understood? Let us do one by one. Battery connected. All these have come in examinations, different examinations. Okay. All these are important. I can show you on the paper. All right. Right. Your teacher made it. Yeah. But you know, they'll be taking in a different way. But if you know this technique, it's going to be very easy for you. All right. Just know this. Just know that battery connected, voltage constant, battery removed, charge is constant. And I'll do one repeated board examination question also, 3-mark numerical. 3-mark numerical in class. Okay, just write this down. Just write this down. Write this. Write and not first. Write and not first. Write and not. Write and not. Mark it as very important. Battery connected. Battery connected means what? Who will be constant? Battery connected means voltage is constant. Say it at least once. All of you understood? Everyone online? Write this. Battery connected, voltage is constant. Okay. Battery connected, voltage is constant. Battery removed. Removed is sometimes given as disconnected. Okay. Don't say you haven't seen it. Okay. Removed is same as disconnected. Okay. Battery connected, voltage is constant. Battery removed or battery disconnected, whatever is stored, charge will be constant. The source has stopped. Battery removed means source has stopped. So source stops means there is no flow of charges anymore, right? Charge will be constant. Correct. So when you remove the battery, the source stops. Source stops means there is no further inflow of charges. Got it? Charge will be constant. Okay, now let us write this. Number 1, slab introduced. Number 1, slab introduced, battery connected. Write it. Case number 1, slab introduced. You are introducing a slab and battery is still connected. Okay. First you write this on the margin. Capacitance is what? Epsilon 0 A by D. Capacitance with a conducting slab is what? Epsilon 0 A by D minus T. Correct. Here, look at the denominator. Denominator decreases, right? Correct. Correct. You can say denominator decreases. Denominator decreases, which implies capacitance increases. When denominator decreases, capacitance increases. When denominator decreases, that is denominator. When denominator decreases, capacitance increases. Oh, last slide. Okay. So you can write first one, capacitance increases. Write it, capacitance increases. Okay, what do you think about voltage? Voltage is battery connected, right? Battery connected means voltage is constant. Voltage is constant. All right. Right, Sishan? Now, how about Q? Q is equal to C into V, right? Look at V and see what happens. Here, V is a constant, right? V is constant. What happens to C? C increases. V is constant, C increases. So, charge also increases. Okay. Last one, energy. Energy. What about energy now? Half QV, right? Oh, tell me about this. Half is constant. Here, V is constant. What about Q? Q increases. So, energy also increases. Got it now? dr increases means denominator decreases here. This is denominator d only, no? This denominator is d minus t, no? So denominator is less in the second case, right? Denominator decreases, so capacitance will increase. Got it? Okay. Right. Okay, number 2. You can write second one. Second one you can write. Tell me when this is done. Second one, slab introduced. Slab introduced. Battery removed. Slab introduced, battery removed. Slab introduced, battery removed. Okay. Tell me, slab introduced, battery removed. First one. What about number 1? Slab introduced. Slab introduced means capacitance will increase. Right. When you introduce the slab, capacitance will increase. Correct. When you introduce the slab, capacitance will increase. Okay. When you introduce the slab, capacitance will increase. Whichever slab you introduce, be it conducting or dielectric, capacitance will always increase. Number 2, what about this case? Battery removed. I said battery removed means charge is constant. So charge will be constant. Now third one I can write. Third one I can write. I have written C and Q, right? Never ever forget this. V is equal to. Very high chance of coming in final examinations. Okay. I'll show you the previous board questions. V is equal to Q by C. V is equal to Q by C. Tell me about both guys. V is equal to Q by C, right? What about Q and C? What about Q and C? Right. Now, what about Q and C? Here, Q is a constant. Numerator is constant. Denominator increases. Denominator increases. So, V will decrease. V will decrease. Last one, energy. Energy, I said I have 3 equations, but I have to choose the equation judiciously. Which equation? The equation with constant quantity in it. The equation with constant quantity in it. Who is the constant here? Q is the constant. So half QV. Okay, half QV. Q is constant. V decreases. Correct. Half is constant. Q decreases. So Q is constant. V decreases. If V decreases, what will happen? Energy also decreases. Correct. Correct. Capacitance will increase. Capacitance will increase no matter what kind of slab you are introducing, right? Irrespective of the slab you are introducing, capacitance will increase. Am I correct? Capacitance will increase. Battery removed means charge will be constant. Then voltage, potential is what? Q by C. Here, Q is constant, C increases, so V decreases. Last one, energy is half into Q into V. Q is constant, but V decreases, energy will decrease, right? So let us make it quick. Third case, slab removed. Slab removed. battery connected. Slab removed. It is just the opposite of slab introduced. Slab removed. C is capacitance. Yes, Aisha. Slab removed, battery connected. Slab removed, battery connected. Slab removed, battery connected. Slab removed, battery connected. Okay. Slab removed, battery connected. Okay, first one. Tell me what? What will happen to capacitance? Capacitance will decrease. You know why? Because when you introduce the capacitance, when you introduce the slab, capacitance increases. So when you take it out, just the opposite. Correct. So see, when you introduce the slab, capacitance increases. So when you take it out, just the opposite, capacitance decreases, right? Rest is as we did, capacitance decreases. All right. Number two, what about the second one? Battery connected. Battery connected means voltage will be constant. Battery connected means voltage will be constant. All of you online, do you follow? Voltage will be constant. Third one, C and V are written. I can write Q. Q is equal to CV. It's all common sense. V is constant here, but C decreases. So charge also decreases. Fourth one, energy. Energy is what? You have the equation with V in it, right? Half QV. Half QV. Look at this and tell me. Half is a constant. V is a constant. Q decreases. So energy also decreases. Okay. Fourth case. Make it quick. All of you got it? Everyone online? Okay. One second, last slide. Make it quick, Chris. Take a screenshot instead, Chris. Okay, right. So write this. Next is what? Slab removed. Slab removed, battery disconnected. Or battery removed. Slab removed, battery removed. Slab removed, battery removed. You should have a clear conceptual understanding. Then only you can do that numerical, which has been asked many times in examination. Okay. I'll be doing it in class. 3-mark question. So number one, slab removed. Slab removed means capacitance will decrease. Number two, then battery removed. Battery removed means charge will be constant. Number three, V and C and Q are written. V will be Q by C. What about this? V is equal to Q by C, right? Q is a constant. C decreases. So denominator decreases. This will increase. Last one, energy. Which equation you are going to choose? Half QV. Or even Q square by 2C is fine. You should choose the one with Q inside. Okay, Q contained. All right. How about this equation? Half is a constant. Q is constant. V increases. So energy also increases. Got it? Energy also increases. Got it? Half QV energy increases. So 4 cases, slab introduced, battery connected, slab introduced, battery disconnected. Then what? Slab taken out, battery connected, slab taken out, battery disconnected. Okay, make it quick. All of you finished? All of you online? Arrow, horizontal arrow represents constant, Razi. Okay, all right. So let's move on. Next one. Okay, fifth one. You can write, plates are moved apart. Plates are moved apart. Make it quick. Plates are moved apart. Battery connected. Battery connected. Plates are moved apart. Look at this. In questions in board examination, you might see using insulating handle. What will happen otherwise? Look at this. Imagine these are the plates. What happens if I hold them by my hand and then pull them apart? Charges will leak through my body, right? The plates are holding charges, right? My body is a conductor, right? So charges will leak through to your leak through your body. Got it? In order to prevent that from happening, they will say like you are holding the plates using insulating handle, like plastic handle. Understood? And pulling them apart. What will happen if you pull them apart? Capacitance is originally epsilon 0 A by D. When you pull them apart, spacing increases, right? Spacing increases. It's not about introducing slab. Spacing increases. D will increase. D will increase, right? D will increase means C will decrease. Correct. See, these are the plates. You are moving them apart. Apart means what? The spacing is more now. The distance is more now. Correct. Distance is more means what? Tell me, Kripa, look at this. These are the plates. These are the plates, right? Capacitor plates. Now they have a spacing of D. Now look at this. You are moving them away. What about D now? D is more now, right? That's it. Okay, I can draw it. Look at this. In case number 1, these are the plates. Look at the separation between them, D. Now imagine they are now here. The plates are now here. What about D now? It is a much bigger D now, right? Correct. D is more now, increases. The spacing increases. All right, the plates are far apart now. When distance increases, denominator increases. Capacitance will decrease. So what is the effect of moving the plates apart? Capacitance will increase. Correct. Oh, capacitance will decrease, right? Capacitance will decrease, right? Okay, let us write. Let us write. Start writing. Just write it here. Just write it on the margin. Capacitance is epsilon 0 A by D. What happens when D increases? Moving the plates apart, right? D increases means capacitance decreases. D increases means yeah, no problem. I can show you the last slide. You finish it off anyway. Right. So just write this. Write this. Plates are moved apart, battery connected. Make it quick. Capacitance is epsilon 0 A by D. D increases, capacitance decreases. All right. D increases, capacitance decreases. Then, so first point. What do you think about capacitance? Capacitance decreases. Then I said, battery connected. Battery connected means voltage is constant. You can write it very quickly now. Q and V and C are written already, right? Now write Q. Q is equal to C into V. Q is equal to C into V. Here V is a constant. C decreases. So energy, charge also decreases. Last one, energy. Energy is what? Energy is half QV. Right, half QV. What about this one? Half is a constant. Q is a constant. Sorry, half is a constant. V is a constant. Q decreases, right? So energy also decreases. Let's make the 6th case now. Write the 6th case. Plates are moved apart. So all these cases can be done if you know only 2 things. Battery connected, voltage constant. Battery removed, charge is constant. Plates are moved apart. Battery removed. Do the same way. Nothing to learn by heart here. Number 1. Plates are moved apart. Battery removed. Plates are moved apart. Battery removed. Tell me what you're going to get. This is first one. Plates are moved apart. Battery removed. Moved apart. What will happen? Moved apart means distance will increase. Capacitance will decrease. Capacitance decreases. Number 2. Battery removed means charge is constant. Charge is constant. Number 3. V will be Q divided by C. Q is a constant here. C decreases. So voltage will increase. Last one, energy. Energy, we have an equation. Q equation, right? Energy equation is Q, right? What is it? Half QV. Half QV. Half is a constant. Q is a constant. V increases, right? V increases means energy also increases. Okay. All of you got it? 7th and 8th cases very quickly. This is plates are moved apart, right? Plates are moved closer now. Next. Okay. You finished writing this, all of you online? So next case, 7th one, make it quick. Plates are moved closer. Plates are moved closer. Battery connected. Plates are moved closer, battery connected. Plates are moved closer, battery connected. Make it quick. I have to do a couple of more questions. Plates are moved closer, battery connected. Moved closer. Capacitance is epsilon 0 A by D. Moved closer means distance will decrease, right? Moved closer means distance will decrease, right? Distance will decrease. So denominator will decrease. Capacitance will increase. Am I correct? So when you move the plates closer to each other, look at this. You're holding them using handles and then you are moving them closer like this. Distance is decreasing, right? Distance is decreasing means capacitance will increase, right? Okay, so first one, capacitance will increase. Then I said battery connected. Battery connected means voltage will be constant. Voltage will be constant. Now the third one, we got C, we got V, next is Q. Q is equal to CV. Look at this and tell me. Q is equal to CV, right? Here V is a constant. C increases. If you understood the concept, you're never going to forget this. All right, CV. Last one, fourth one, energy. Energy I'm choosing half QV. My equation should contain the constant V. Correct. Now tell me about this. Half is a constant. Here V is a constant. Q increases. So you will have energy increasing. Now eighth one. Plates are moved closer. Battery removed. Plates are moved closer, battery removed. Plates are moved closer, battery removed. Tell me, number one. Plates are moved closer, capacitance will increase. Number two. Battery removed, charge will be constant, Q will be constant. Number three. V is equal to Q by C. Right? Here, Q is a constant. C increases. Q is a constant, C increases. Denominator increases. The value will decrease. Look at this. C increases, right? Q is a constant. Q is constant, right? Q constant, C increases. Denominator increases. This value will decrease. Fourth one, energy. Energy is half QV. Half QV. Half is a constant. Q is a constant. V decreases. V decreases means energy also decreases. Okay. Got it. Now, can you take the paper? I'll tell you which all questions. I've sent the paper to the group. Can you check the paper, all of you online? I'll tell you 2-3 questions from this. I'll be doing them in next class, but I'll tell you which all questions would come from this part, would belong to this part. All capacitor questions are included in this paper. Okay. Question number 4. Question number 4. Question number 4. Question number 10. Question number 4. Question number 10. Question number 11. All are previous questions. Question number 4, 10, 11. Try them at home. The electric field part you won't be able to get. Next class I'll do. Electric field part. Okay. Question number 4. There are 3 homework questions. Question number 4. Question number 10. Question number 11. I'll be doing them in class. All are previous questions. Okay. All are previous questions. Okay. Right. Now, whichever question comes your way, you can do it with these concepts. All right. You have to know 2 things. Which are they? Which are they? Number 1, voltage is constant when battery is connected. Voltage is battery removed, charge will be constant. Okay. One last point, I'll wind up for the day. Right heading, common potential. Common potential. Common potential. That's the end of today's discussion. So all of you online understood this? All right, listen. One last point. Hey, listen. Right. There is something called common potential. Listen here, please. It is not, hey, listen. It is not explicitly given in the reader anymore. But chapter and exercise has question on this. All right, I'll tell you. Look at this. I'll tell you the scenario. Just imagine we have a bucket of water. All right. Like I always tell you. Another bucket of water with a lesser amount of water. If you connect them through a pipe, what happens? Water flows from higher level to lower level till both have a common level, equal level, right? Common level. Similar way, if I take my hot coffee and add some cold milk into it, what will happen? Heat flows from hot coffee into cold milk until both settle down for a common temperature, right? So did you notice something? You know, in this case, water flows from higher level to lower level till both have a common water level. And in the other case, heat flows from higher temperature to lower temperature till both have a common temperature. Similar way, look at this. I'm going to take a capacitor this time. This is capacitor C1. It is charged to potential V1. Another capacitor C2, which is charged to potential V2. And I connect them in parallel like this. What will happen? Charge will flow from higher potential to water actually flows from higher level to lower level. Heat flows from higher temperature to lower temperature. Charge flows from higher potential to lower potential till both have a common potential. Common potential. What is the equation for common potential? It is C1V1 plus C2V2 divided by C1 plus C2, common potential equation. Now, this is actually obtained from conservation of charge. Law of conservation of charge. Charge can neither be created nor be destroyed. Okay, look at this. C1V1 plus C2V2 divided by C1 plus C2. C1 will be given, V1 will be given, C2, V2 will be given. You will have to substitute and find out. But again, you know, in this case, positive of this plate is connected to positive of this plate. Negative of this plate is connected to negative of this plate. What if it is the other way? Don't write now. Positive is connected to negative. Negative is connected to positive. Okay, that is a competitive examination question. Again, in your school only, they did it last time. I'm 100% sure that is never going to come in board examination. I can sign it on a paper if you want. All right, I'm putting it on record. But in that case, the equation changes to C1V1 minus C2V2 divided by C1 plus C2. Got it? If plates of opposite polarity, that is plus is connected to minus, minus is connected to plus, it becomes C1V1 minus C2V2 by C1 plus C2. But it is not needed for exam. It's a competitive examination question. Okay. So just take it this way only. Positive is connected to positive. Positive is connected to positive. And negative is connected to negative. And in that case, the common potential will be C1V1 plus C2V2 divided by C1 plus C2. And in this process, energy will be lost. Why? Because the wire gets heated up. As the charge flows, wire gets heated up. Eventually, if you touch the wire, you will feel the heat. All right, the energy lost by way of heating. It is given by half into C1 C2 by C1 plus C2 into V1 minus V2 the whole square. All right, learn the equations only. 100% sure the derivation is not there. It is deleted. Even if your teacher teaches us, you don't have to learn it. Half into C1 C2 by C1 plus C2 into V1 minus V2 the whole square. If you need it, I can teach outside. No problem. Okay. Second thing, look at this. In some numericals, they will say one capacitor is uncharged. If you see uncharged, take its potential as 0. Okay. One of them will be, they'll be saying like one of them is uncharged, like the question, homework question I gave. Understood? If you see uncharged, you can take what? If you see the word uncharged, just take that potential as 0. Understood? This is supposed to be one of the most important slides in this part of the chapter. All right. Okay, it is not given in the reader, like I said, but exercise has a question on it. It is actually frequently asked question in competitive examinations also, NEET and JEE. Got it? Board examination question also. Okay, nothing, direct question only, numerical. You can check the last 10 BS papers to see how many times it has come. All right. What is common potential? Like I said, you will definitely see this in half-yearly exam. Two capacitors side by side. One capacitor is C1. First capacitor is C1, charged to potential V1. Second capacitor is C2, charged to potential, say something please, V2, right? And they are put in parallel connection. Positive of first capacitor is connected to positive. Negative of first capacitor is connected to negative of second. In that case, tell me, charge flows from higher potential to lower potential. Charge flows from higher potential to lower potential until both the capacitors have a common potential. Common potential. What is the equation for common potential? C1 V1 plus C2 V2 by C1 plus C2. Say it again. C1 V1 plus C2 V2 divided by C1 plus C2. C1 and C2 are the capacitance values. V1 and V2 are the potential values. All of them. No, only two cases. That will be very complicated. C1 V1 plus C2 V2 divided by C1 plus C2. C1 V1 plus C2 V2 divided by C1 plus C2. This is done using conservation of charge. Total charge before sharing is equal to total charge after sharing. Okay, which is not needed anymore. Just learn the equation. That's enough. All right. And secondly, like I told you, when you do this stuff, tell me what's happening. Energy is being lost. Why? Because the wires are having flowing charges, right? Joule's law will act. Joule's law will work. Okay. Because there is resistance on the wire. Resistance on the wire. This wire has resistance, no? So the wire gets heated up. So how much of energy is lost? You know, delta U is equal to half into C1 C2 by C1 plus C2 into V1 minus V2 the whole square. Say it again. Half into C1 C2 by, say it at least once, C1 C2 by C1 plus C2 into V1 minus V2 the whole square. Okay. And if they say one of the capacitors is uncharged, take its potential as 0 and put it in this equation. Got it? You can derive this very easily. Try this at home. First, find the energy of this capacitor, half C1 V1 square. Then find the energy of this capacitor, half C2 V2 square. Add them up. That is the total energy. Okay. Then find the final energy. How to find the final energy? Half into C1 plus C2. They are in parallel now. Effective is what? Oh no, in parallel combination, effective is what? C1 plus C2. Don't you remember? Series combination 1 by C is equal to 1 by C1 plus 1 by C2. Parallel combination C1 plus C2. We even did many questions like this. Do you remember? Do you remember this question? Right. Okay. Half into C1 plus C2 into V square. So you find the total energy before sharing. You find the total energy after sharing. Take the difference. You will get this equation, which is a very complicated derivation, which you are not supposed to learn. All right. In case your teacher asks, do not learn it. Okay. So just know this equation. That's it. Common potential is C1 V1 plus C2 V2 by C1 plus C2. Energy lost is half into C1 C2 by C1 plus C2 into V1 minus V2 the whole square. Then uncharged potential will be taken 0. Try those homework questions 13 and 19. Okay. Shall we wind up for the day? All of you got this?